Okay, so for our third problem for our lessons 4 and 5, triangles and quadrilaterals, let's try this question. ABCD is a quadrilateral such that the measurement of angle B is equal to 90 degrees. A circle is drawn inside quadrilateral, which is a trapezoid, that touches the sides AB, BC, and CD, and DA at PQRS respectively. If BC is equal to 38, and CD is equal to 25, and BP is equal to 27. What is the radius of this circle? Okay, so first observation, what can we observe with our circle here? For a circle, all of the radius, always remember this, all of the radii are congruent. They're all the same. Okay, so therefore for this circle, we have here RO is just the same as SO. And since these two sides are congruent to each other, therefore DR and DS must be the same, would have the same values as well. So therefore DRSO would be a square, right? Because they have 90-degree angles, all of the angles are 90 degrees, and all of the sides are the same. Now, if we try to look real closely at the problem, we're ignoring the three side measurements that were given. So let's try to utilize them for this problem. Okay, so for this one, it says here that we have here DR and RC. Okay, now DR and RC, okay, for this problem, since we know that DR is parallel to SO, and we know that SO is the radius of the circle, so therefore SO must be congruent to DR. So therefore DR, since SO is a radius, therefore DR must have the same value as the radius. And since we know that this is 25, therefore RC must be equal to DC, the entire side measurement, minus DR. Okay, so therefore RC should be equal to 25 minus DR, which is just the radius. Okay, and we have a theorem about circles. Okay, so we have here point R, and CR and CQ, these two lines, we call them tangents. Now what are tangents? Again, dear students, tangent lines are lines on a circle that intersect with the circle at only one point. Okay, and we call that point the point of tangency. So that's where the intersection between the line segment and the circumference of the circle happens. So that's the point of tangency. Okay, it says here, one of the theorems about circles is that if you have two tangent lines, we have two intersecting tangent lines, so they must be congruent to each other. So therefore, if RC is equal to 25 minus R, so CQ is going to be equal to RC, according to one of the theorems about circles and their tangent lines on two tangent lines. So therefore, CQ must also be equal to 25 minus R. Okay, so therefore, this side measurement here should be equal to 25 minus R. Now, we know that QB here is missing, but we know that the value of CB, now CB is equal to 38. If CB is equal to 38, and we know that CB is the sum of CQ, line segment CQ, and QB, and we already know the value of CQ, so therefore CB for this one is going to be equal to 38. Okay, so that's given, is equal to CQ, which is 25 minus R, plus QB, okay, for this one. So let's try to simplify this. So therefore, 38, okay, 38 minus 25 plus R is equal to QB. So therefore, what's 38 minus 25? So that should give us 13. So therefore, 13 plus R is equal to QB. Now, QB here, we've already found the measurement of QB, so that's 13 plus R. So QB here is going to be the same. It's going to have the same side measurement as PB. Why is that so? Because PB and QB, what are those lines? As we mentioned a while ago, so they are tangents. Okay, if they're tangents, they're going to be congruent. They're going to be the same to each other if they intersect the circle at, since they're tangents, if they intersect the circle at one point. Now, since PB is equal to 27, and we know that QB is equal to 13 plus R, and we know that QB is equal to PB, therefore we can equate these two terms. So you have here 27 is equal to 13 plus R, so therefore the radius is going to be equal to 27 minus 13. And what's 27 minus 13? So that should give us 14. So therefore the measurement of the radius of this circle is equal to 14. Now, we didn't really solve for it by using the area of a circle, pi r squared, or the circumference, pi r. So we solved it indirectly, but we used a very special theorem for this problem. So that's the tangent theorem, wherein when two tangent lines intersect, and their point of the intersection is a common point exterior to that circle, so those two tangent lines must be the same, or they are congruent to each other. And based on what we saw, we already found the value of the radius, so that's equal to 14. And that's how we solve this problem.